Yes, let's start. Let's give exact equation, and if our equation is exact, how to solve this exact equation? It's okay here, and let's define the exact equation, and take the first order. For example, here first order derivative. Look at the coefficients n, and also plus m is equal 0. It's okay, or our equation in this form, mxy times dx plus nxy dy is 0. And these equations, is okay, are called exact if and only if and the left side is equal and the d phi xy for some differentiable phi xy, and here fxy, if satisfied this one, we called, and our equation is called exact. And here phi xy is equal c is the implicit general solution of our equation. It's okay, and so our equation is exact if and only if and the partial derivative with respect to y is equal partial derivative with respect to x. It's okay, this one. So what is the reason? And here look at the definition of the exact. If and this one is equal the phi. What's the phi? We know and this one from and the calculus and the class, and differentiable of a function phi xy is equal phi sub x dx phi sub y dy, and here phi sub x and the partial derivative with respect to x, phi sub y partial derivative with respect to y. It's okay. If and this one is equal differential of a function phi, so our equation is exact. And also, what's the solution? Look at the here, and the phi xy is equal c. C is a constant. This one is the general solution of the differential equation. It's okay. So, and how to find the natural question here if our equation in this form and satisfy this condition, if exact, that is this our equation is exact. So how to find the solution? It's okay. So look at this one, and also we know that and the phi of x is means and the d phi over dx plus d phi over dy this one. So this one is equal this one. So compare the coefficient of dx. It's okay. Coefficient of dx m here, but right side coefficient of dx d phi over dx. So what and also n should be d phi over dy, and right. And so we obtained this equality. Phi sub x should be m, phi sub y should be n. And the first partial derivative with respect to x should be m, partial derivative with respect to y should be n. It's okay? So using the both and the equality and here, so solve for phi, and so we obtain implicitly our solution. It's okay? So, of course, and here, how to find the phi, and let's give an example. It will be better, and to understand this method, it's okay. How to find the general implicit general solution if our equation is exact. It's okay. So let's give an example, but be careful here, and here. And coefficient of dx is denoted by m. Coefficient of dy is denoted by n. So, but and also, and here, critical point here, our equations are exact if and only if dm over dy, dn over dx should be. It's okay. And what's the reason here? If we know and the exact equation, look at the exact equation, m should be this one, n should be this one. So we have this one and this one. So how to get under this equality? and take this one. D phi over dx is m. So, and take the derivative, partial derivative with respect to y. So we obtain d square d phi over with respect to y, dy dx, and is equal dm over dy. Is okay? And also we have under this one, because our equation is exact, d phi over dy is n. So take the partial derivative with respect to x here. So d square phi over dx dy is equal dn over dx. It's okay? So, and also we know that, and from calculus, and this and the derivative, use the different color, maybe it will be better. This one always is equal this one, order it is not important. So left side is equal, so should be right side is equal. So we obtain this condition. If our equation is exact, so we obtain is this one, or satisfied under these conditions, so our equation is exact. If and only if condition. It's okay? Any question? How to get this condition? Any question? I think it is clear. If the coefficient of dx is dx, this one is d phi over dx. If n is equal d phi over dy, and they take the partial derivative with respect to y, partial derivative with respect to x, so we obtain and this one and this one, so we obtain our condition. So we know here how to check that our differential equations exact or not. Use this equality. It's okay. This one. So let's give an example to understand this method. It's okay. How to check that our equation is exact or not. First step, and our equation is this one, and our question here, and solve this differential equation. It's okay. Solve this differential equation. And first step, identify our equation. Our equation contains dy dx y prime, that is, so only highest order, and the order is first order differential equation. So first order differential equation is a linear, not linear, because, and look at the dy over dx, and the coefficients contains y, not only x. So and also right hand side, and will be this one. So this one is non-linear first order equation. And also this one is separable or not separable, because look at this one, coefficient of dx not x, contain x, this one not contain only y, so this one is not separable. And also maybe this one is non-separable, maybe transform into the separable equation. This one it is not valid, because and homogeneous or not y over x, and it is possible, and here y over x, f of y over x is okay. dy over dx is equal f of y over x, and this one it is not valid, this form. So not separable, but it is not possible to separate and separable equation. And then, but first order differential equation, maybe this one is an exact equation. It's okay. Let's check the exact equation or not. And this one is called m, because coefficient of dx. Coefficient of and the dy is called n. It's okay. So how to check that exact equation or not? And take the dm over dy is equal dn over dx, because partial derivative dm, m is d phi over dx, and the partial derivative with respect to y is okay. So, and the partial derivative with respect to x in here, and then should be this one. And this one, and the first one, and this one is denoted by partial derivative with respect to y is denoted by m sub y. This one is denoted by n sub y. N sub y means partial derivative with respect to, sorry, this one should be partial derivative x. It's okay. So, and how to check that exact or not? This one should be this one. Yes. If m is this one, it's okay. And m is this one. It's okay. M is this one. So m sub y. M sub y means partial derivative with respect to y. And derivative and x, and consider x as a constant. It's okay. If and they take the derivative with respect to y. So, and this one is m. So partial derivative with respect to y, and x consider as x as a constant. So cosine x is a constant. Partial derivative with respect to y, and then y is 1 times cosine x. Yes. Plus partial derivative with respect to y, and this one is a constant, e to the y. So we obtain 2x e to the y. It's okay. And the next one, our aim to compute n sub x, and take and the coefficient of dy n and derivative with respect to x. It's okay, with respect to x, and means consider y as a constant. It's okay. So sine x, partial derivative of and with respect to x, sine x, cosine x, and this one is a constant, x squared 2x times e to the y, and minus 1 plus 0. It's okay. So we obtain n sub x, partial derivative with respect to n here. It's okay. And then check that, and this one should be this one is equal. Yes, this one is equal this one. So m sub y is equal nx. So our equation is exact. So our equation is exact equation, and we know that how to find the general solution of exact, and this one is and the phi xy. It's okay. Phi xy is c, and our aim is to get the phi function phi. It's okay, implicit general function, and then how to find, but use some information, and what is the m, and we know that m is a coefficient of dx. We know, and this side, look at the let's come back differential equation, and this one should be d phi. It's okay, d phi, and differential of and phi, and means, and this one should be phi of phi sub x, phi sub y. This one should be m, this one should be n. Okay, and then use this equality, and phi sub x should be m, and also phi sub y should be n. It's okay. Use and this and the equality find the and the function phi. It's okay. M is this one, and this one should be phi sub x. Phi sub x means d phi over dx. If d phi over dx right here is equal, sorry, d phi over dx is equal y cosine x plus 2x e to the y. we obtain under this one. So how to find the phi is okay. And so rewrite this one. We obtain d phi over dx and take the integral. It's okay. With respect to x. It's okay. So we obtain phi xy integral in this one. It's okay. This one. So take the integral and here, but and consider y and here integral with respect to x means and consider y as a constant. Be careful. So integral of y cosine x, y is a constant cosine x. Integral cosine x is sine x, and this one constant and integral to x is x squared. It's okay. Plus C and the integration constant, but here and the y and the here first of all and the consider y as a constant, so not and the c and it should be h of y, function of y, because what is the reason, we claim that take and compute to this integral, so we obtain and the phi is this one plus h of y. H of y is a function of y, and we claim that this one should be h of y. What's the reason? Because and take this one and compute to phi sub x here. It's okay, phi sub x, and means and the derivative with respect to x. Y is a constant, so y cosine x plus this one with respect to x derivative and 2x e to the y. Derivative with respect to x, and we know that y and consider y as a constant, so this one is a constant plus 0. Yes, we obtain this one. It's okay, be careful. Because we have the partial derivative, so we obtain phi and they take the derivative with respect to x, and means y, consider y as a constant. It's okay, be careful. And here our aim here, solve this differential equation, and means find the solution of the general solution of differential equation. This one is exact, so our solution, implicit solution, phi xy is equal c. Our aim is to get phi xy, but here phi xy depends on h of y. And the next step, find the h of y. What is this function? It's okay. Now let's find the h of y. It's okay, this step. So how to find h of y? We know and at the beginning, and this one is d phi is equal, so and this one is phi sub x dx plus this one is plus phi sub y dy, and means phi sub y is equal this one. Now let's use this one. It's okay? Yes. And we know that d phi over dy is n. What is the n? N this one. Sin x plus x squared e to the y. And minus 1. Use and this information. It's okay? This equation. And we have and the phi here. Phi is this one. Phi this one. It's okay? And so partial derivative should be this one. So take this one and take the derivative with respect to y. With respect to y, and means x, consider x is a constant. So with respect to y, sine x. With respect to y, take the derivative with respect to y. E to the y x squared. With respect to y, h prime y. It's okay? With h prime y means the but not partial, because and this function depends on only one variable, so this one is not partial derivative, ordinary derivative. The h over dy is not by h prime. And here we know that our equation is exact, so d phi over dy should be n, and means should be this one. It's okay? So this one is equal this one. It's okay. So we obtain h prime y is minus 1. So dh over dy is minus 1. How to get h? And they take the rewrite and integrating both sides, we obtain h of y. And this one, minus 1 times, and this one, minus y, plus here now, plus integration constant c. And so we obtain h of y this one, but ignore c here because, and write the phi. What's the phi? And look at the here phi. Phi is this one. And substitute h. H is minus y plus c. It's okay. Substitute here. We obtain phi. Phi is this one plus c because c. It's okay. But we can omit c. What's the reason? Because let's come back here. Implicit function and R and the solution is a phi of x phi of xy c, any constant. And here let's come back this one and write this one. So y sine x plus x squared e to the y minus y plus c plus and is equal both c, for example. So and the rewrite, and so here y sine x plus x squared e to the y minus y is equal both c minus c. Abuse of notation is noted by capital C, for example. So we obtain this one. It's okay, this one. So what does it, and so, and here we can, and we can omit always, and here integration constant. So take h of y is minus y because, and the phi xy is equal c, and abuse of notation this one is capital C, for example. We get the same result. It's okay, C arbitrary constant because. So, and this one is the general solution of our differential equation. And take the C is 1, we obtain one solution. Take the 100, we obtain another solution, 1 over 10, and so on. It's okay, differential equation. So we get infinitely many solutions, and then this and the solution is called general solution. But implicit and this one, because it is not possible to write the this one is y is this one y of x. It's okay, y is y of x, not in this form. If we get the in this form, and this one is called general solution here, and this one is explicit, but here it is not possible solve for y here, so implicit we obtain the general solution. Any question? Any question about the solution? I hope no question. Okay. One more example. It's okay. Look at this one. First of all, solve for this equation, for example. It's okay. Solve for this equation. And first of all, and identify this equation. This equation, first order differential equation, because contains dy over dx only, highest order, first order here. And so in this one is linear, not linear because contains x and y coefficients. It's okay. And also not separable. It's okay. Maybe this one is exact. Let's check that exact or not. Coefficient of dx is m, denoted by m. This one is denoted by n. So our aim, how to check that exact or not? Be careful, m and the dx, so m sub y, and the coefficient on n dy, and means n sub x. It's okay, should be m sub y. And then m sub y means derivative with respect to y and x, consider x as a constant. So this one is 3x times 1, and this one y squared 2y. It's okay. So n sub x with respect to x, 2x, and this one times y, 1 times y is y. It's okay. So, but this one not equal this one. So, this equation not exact equation. So, question here, if not exact equation, it is possible to solve the and this one if our problem here, our problem is not exact equation, our equation. And our aim is to solve solve this one. It's okay. Solution. What is the solution of and sorry. Our aim is to solve the and this equation, but this equation not exact. Not exact. So maybe this equation transform into the exact equation, and then we know that how to solve this exact equation using this method, and we know that m sub y and exact means m sub y is equal n sub x, and how to solve and this one is okay. So and d over dx dy should be d square over phi dy dx should be, and then using this equality and solve for and the phi is okay, integrating both sides and so on. So we get solution of the exact equation, but here not exact. So question here and this step is okay, how to transform and this problem into the exact equation problem. It's okay. So and we claim that let's define the integrating factors, and using this factor multiply mu is the integrating factor here, and take the non-exact equation, multiply and such mu, and then we obtain this step here, multiply mu is okay, our equation is 0, so multiply, and this equation, new equation is exact. So question, what is the and these and how to find these mu? It's okay, these mu. So and take the our equation this one is 0, and multiply by mu times this one, mu times 0 0 is okay. So we obtain new equation, but if and this equation is exact, new equation, it's okay, although and the mu dx and dy is 0 is not exact. This equation, sorry, this and this product and it gives and the new equation multiplied by mu is exact, but and the m dx in dy not exact for some function mu. It's okay. Then such a function mu is called integrating and the factor of the equation. So and the question, it is possible to find the mu. It's okay. Yes. And but sometimes it is possible, sometimes not. So and some of course some non-exact equation and take the not exact equation here, it's okay, and sometimes it is possible to get the exact equation, sometimes not, it's okay. So if we get that exists mu and such that and the mu times this equation and gives the new equation is exact, sometimes it is not possible to get the mu, it's okay. So and if we have the and these mu, how to find the mu if our equation transform can be transformed into the exact equation, it's okay. So and let's compute to this one. We know and the m here and the n is okay, our equation not exact, and this one we know m is the coefficient of dx and dy. So compute the partial derivative m sub y minus n sub x over n. Look at this quotient, it's okay. this quotient is a function of x only, not contain, and is a function of x only means this and the quotient contains only x. It's okay, not contain and the y. If this one is a function of x, for example, denoted by p of x, yes, we obtain mu. It's okay. Mu is a function of x e to the p of x dx. P of x is this quotient. It's okay. This mu is called integrating and the factor depending on x only. It's okay. Sometimes this one it is not is a function of x, contains x and y. It's okay, y. Not and the function of x only. It's okay. So, and the next step, look at the other quotient. Other quotient n sub x, n sub x, n sub x minus m sub y over m. Be careful here. Look at this one, n, n. And the x here, so this one is of a function of x. This one is m, this one is should be m, this one is y, this one is a function of, should be function of y. If there exists such mu, it's okay. So if, for example, and the first quotient is not function of x, so you have to check these quotients, second quotient, this one. It's okay. So this one should be function of y. If this one should be function of y, what's the mu? Mu is a function of y e to the qy times dy integral qy dy. It's okay. So, and we obtain mu, and what's the next step? And take our equation here, multiply by mu, and then we obtain new equation. New equation is exact, so we know how to solve the exact equation. It's okay. So, any question about the theory of here? Any question? No question. Okay. Now, let's give an example to understand this math. It's okay. And this one is maybe and the previous example. This one is okay. This one. Let's come back our equation. It's okay. Last example. Last example, not and the exact equation. It's okay. So our aim, if it is possible to get the and the check that mu, such mu integrating factors is noted by IF. It's okay. If we get IF and then multiply mu, and then we obtain exact equation and solve this exact equation. It's okay. So let's take this example. It's okay. This differential, not exact differential equation. Use this and the method. It's okay. Yes. And look at this one, the first derivative and the exact equation or not. Let's check that. This one is denoted by m. This one is denoted by n. M is this one, n is this one. It's okay. So, and how to check that exact or not? And take this one is the coefficient of dx, and means take the derivative with respect to y. And take this one, coefficient of y, and then take the derivative with respect to x. It's okay. So compute this one is not equal, so not exact. So our aim is to get the exact equation by using the mu. It's okay if there exists the IF and this one is mu. It's okay. Let's see that. And so our aim is to compute this quotient m sub y minus nx n. M sub y, yes, let's compute the m sub y, and we know and the m sub y. What's the m sub y? M is this one, derivative with respect to y, 3x plus 2y. It's okay. Take this one, compute the derivative with respect to x, and this one 2x, this one gives 1 times y, y. So this one is not equal this one. So this one is not exact equation. So our next step, it is possible to get that there exists a mu such that multiply mu and we obtain exact equation. So now and compute these quotient. Be careful, and here these quotient m sub y minus n x, and this one should be n, and also function of x should be. It's okay. So let's compute these quotient. M sub y, substitute 3x plus 2y, and minus n sub x over n. N is this one. Yes. So we obtain, yes, x plus y, and they rewrite this one, x plus y times x, and they cancel, and this one we obtain 1 over x. 1 over x is the quotient. This quotient gives a function of x, so p of x, this one. It's okay, not contain y here. So yes, this quotient preparate to get the mu if. It's okay. So, and the formula for mu e to the integral p dx. It's okay. Px is 1 over x. So, and this integral gives ln x. We know that ln x, e to the ln x is x. So mu this one. So means take our differential equation, multiply by x. So we claim that new equation should be exact. So multiply x, and then we obtain this one. So, and look at this one. This one new equation. This one is m. This one is m. This one is n. Exact or not? And how to check that exact or not? And m sub, we claim that this one is an exact equation. It's okay, exact equation. Let's see that. M this one and this one. So m sub y, yes, this one plus 2xy. N sub x, oh, sorry, m sub y. How to compute to this one? Sorry. M sub y, partial derivative with respect to y, and the x, consider x as a constant. So 3x squared times 1, this one, plus partial derivative with respect to y, 2xy. It's okay? And this one, compute to, yes, n sub x is equal. N sub x, partial derivative with respect to x. Y, consider y as a constant, x cubed 3x squared plus 2xy. Yes, is equal. Yes, our equation is an exact equation. Okay, so, and we know how to solve the exact equation. It's okay. So how to solve? Using we know that, and the sun is should be phi sub x, m, n is phi sub y, and use phi sub x is m. It's okay, and our aim is to find the phi. It's okay if phi sub x is m. Phi sub x is m. M is this one. It's okay. How to get phi? Integrating both sides with respect to x. Integral. So, and with respect to dx, with respect to x. So we obtain, yes, 3, and y is a constant here, 3x squared, x cubed y. And this one, x squared over 2y squared plus integration constant h of y, because what's the reason? With respect to x, because it's okay, integrate. So we obtain phi. Phi depends on h of y. The next step to get h of y. How to get h of y? We know when the distance is exact, so means another and equation, and we know phi sub y should be n. And what's then? X cube plus x square y. Use this one. If p sub y this one and the phi this one, it's okay. Our aim is to take the derivative with respect to y. And the phi here, take the derivative with respect to y, it's okay. And consider x as a constant. And with respect to y, x cubed. With respect to y, 2 times 2y over 2. So we obtain this one. Take the derivative with respect to y, h prime y. And the distance should be n. N. It's okay? So compare both sides, and then this one is equal to this one. So means h prime y should be 0. H prime y 0. Take the integral with respect to x and y, integrating both sides. So h of y is c, constant. So, and the phi, what's the phi? Phi is, substitute h of y here, phi this one. But be careful in the critical point, and the phi and the solution, not this one. This one is a function of phi. Solution phi xy is equal c. It is important. It's okay, this one. Because this one is a function. For example, take the f of x. Y is f of x is a function. But f of x is equal c or 0 is an equation. It's okay. This one is, and this one. Not the same. It's okay. This one is phi, and this one is phi. It's okay. This one is not solution. This one is a function phi. It's okay. But solution, implicit general solution, phi xy is equal c. It's okay. So this one is the general solution. Yes. Any question? And here, but the last point here, this one is the general solution. It's okay. This one is the general solution of our differential equation, but with which one? Which equation? This one, our equation, multiplied by x, and we obtain in the second differential equation. This one is, and this one is differential equation of the second one. It's okay, this one. But our equation, not this one, and the previous one, this one. But we claim that this one and also solution of the first equation. It's okay. And the method here, take the not exact equation. It's okay. So find the mu. We obtain exact equation, and solve this equation. We obtain the solution and the exact equation. But and we claim that this solution also solution of the given equation, first equation, not the exact equation. It's okay. Non-exact equation. This solution have the same solution. It's okay. Any question? No question. Okay. Let's give and the problem. These problems, homeworks, is okay. Depends on you. It's okay. I think and solve this problem. It will be better to understand this concept. It's okay. And yes, and consider these example. It's okay. Determine whether each of the equation is exact. If it is exact, find the solution. It's okay. And then the next step, show that the given equation is not exact but becomes exact when multiplied by the given integrating and the factor if, then solve the equation. And this one is okay. This one if is okay. The given for the given equation. And the next part C, find an if, this one, and solve the equation. This one is typo. Solve the equation. 1, 2, 3, 4, 5, and it is, and the parts contains 5 equations. It's okay. So let's have a break, 10 minutes, and then we will give this other equation, second order equations. It's okay. Any question? No question. Okay. Let's have a break, 10 minutes, and